Problem F1811, the 30 kilogram rod is released from rest when theta equals 45. So it's a 45-degree angle, and it's released from rest. Determine the angular velocity when theta equals 0. So it's going to slide down, and when it hits the ground, what is the angular velocity right before impact? The spring is unstretched to begin with. So T1 plus V1 plus U equals T2 plus V2. And there's no work. It's released from rest. And so V1 is mgh, and T1 is 1/2 I omega, or T2 omega squared, plus 1/2 k x squared, x being the stretch, not the distance along the x-axis. So h, the original height, is going to be 0.707, or the sine of 45, times the total length, 1.5, times 1/2 of that, because it's at the center, so it's actually going to be in the middle of that. So that's 0.53 is the original height. I is equal to 1/3 ml squared, which is 1/3 times 30 times 1.5 squared equals 22.5. X. So the stretch, the spring is unstretched when theta equals 45. And so we have 1.5 minus 1.5 times 0.707. So this, when it's laying flat, this is the total length of that spring, 1.5, because the spring will be the length of the rod. And then this is the original length, which is 1.5 times the sine of 45, giving the original length when theta was 45. So x is equal to 0.44. Putting everything into the equation then, and we get 30, mass of the rod, 9.81, times h, 0.53, equals 1/2 I, 22.5, omega squared, plus 1/2 30.44 squared, and omega equals 3.36 radians per second.